Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. A student has sent through this question, which comes from the 2020 Extension 2 Math HSC exam, question 13. So we're looking at 13C Part 1. So this question tells us, by considering the right-angled triangle below or otherwise, prove that a plus b on 2 is greater than or equal to the square root of ab, where a is greater than b and b is greater than or equal to 0. And then we've got a little diagram here to help us think about it. So what I'll do for this question is I will work through an approach that involves looking at this triangle and kind of works out the result from there. And because the question has the words or otherwise in there, so it gives us the opportunity to use other techniques, I will also work through just one other of the options that you could have taken to get the marks for this question. So I'll start by writing out what we're trying to prove. So we're being asked to prove that a plus b on 2 is greater than or equal to the square root of ab. Now, before I jump into that, it's probably worth just noting in general, there's something called the AM-GM inequality. So that stands for the arithmetic mean geometric mean inequality. And according to that inequality, in general, if you took n numbers, so here I'll write x1 plus x2 all the way up to xn, and if you add them up and divide by n, so in other words, you take their arithmetic mean, that will always be greater than or equal to the nth root of multiplying them. In other words, the geometric mean. So if I did x1 times x2 all the way up to times xn, and took the nth root, that's called the geometric mean. And this inequality in general says the arithmetic mean is always greater than or equal to the geometric mean. So what we're looking at here is, in effect, this inequality for n is equal to 2. Now, I don't think you could just say by the AM-GM inequality, let n is equal to 2, there you go. I mean, maybe it would be a cheeky way to think about it. I suspect you might not get your marks. Maybe you'd have to prove this result in general first and then let n is equal to 2. Maybe that would be acceptable. But to prove this, you're probably in the world of mathematical induction, I'd guess, would be a way you could go about that. There's probably other ways too. But in the end, we don't need to do that. You don't actually need to prove this general result to get here for n is equal to 2. There's plenty of simpler ways, I think, to go about it. And the one way that the question writer is guiding us to was to use this triangle. So that's the first way we'll look at here. So we've got this right-angled triangle. We're told that the hypotenuse was a plus b. One of the other sides was a minus b. And then the final side was x. And hopefully when you see a right-angled triangle like this, where you've got all three sides, hopefully what jumps out is Pythagoras. So I think that's the natural place to start. So by Pythagoras, what we can say is that the hypotenuse squared, a plus b squared, will be equal to the sum of the squares of the other side. So a minus b squared plus x squared. So we'll just expand both sides. So we'll have the first one squared plus twice the product plus the last one squared equals the first one squared minus twice the product plus the last one squared plus x squared. We've got some common items on both sides. So the a squareds will cancel, the b squareds will cancel. This minus 2ab I'll bring over. So we'll end up with 4ab equals x squared. So therefore x is equal to the square root of 4ab, and I'll just take the positive square root here because we're looking at the length of a side of a triangle, so we're not really in negative length territory. And here I can simplify that to just be 2 times the square root of ab, since the square root of 4 is 2. Alright, so from there, what can we do? How do we get an inequality in here? And the way we can do that is by noting that the hypotenuse of a right-angled triangle is always going to be greater than the length of each of the other sides individually. So the hypotenuse will be greater than this side, and the hypotenuse will be greater than this side. Given we've just found x is 2 root AB, and root AB is in our inequality, it makes sense to compare these two sides, and that's how we get our inequality. So we could say something along the lines of, since the hypotenuse is a plus b, we can say a plus b is greater than or equal to x, which means a plus b is greater than or equal to 2 root ab. And then we divide the 2 over and we end up where we need to be. A plus b on 2 is greater than or equal to the square root of ab as required. So in the end, fairly straightforward, not a lot of complex algebra required, just an appreciation of Pythagoras' theorem and I guess the nature of the hypotenuse being longer than the other two sides.
Panic boom!
So hopefully that all made sense. Now what I'll do, I might turn over and I'm going to look at the or otherwise. So basically one of the other approaches that you could have used to get your marks here. And the approach I'm going to look at was, maybe I guess you'd say, inspired by someone named Mr. Kim Singh, who is a math teacher in New South Wales, and he also has a YouTube channel. And I recently discovered Mr. Kim Singh's YouTube channel. I think the YouTube channel is, if you wanted to go find it, I think it's Jonathan Kim Singh is the title of the YouTube channel. And I think I recently discovered his channel. It was a result of a video I published last year on the chirping crickets HSC question. So it was one of those common content questions between standard and advanced. And it developed a bit of reputation as a difficult question, perhaps even too difficult for maybe for the standard cohort. And I took a look at it and went through my solution, and it kind of got relatively, for me at least, quite a few views. And looking through the analytics on that video, something I noticed is that a lot of the people coming to view that video were clicking through on a recommended thumbnail that had come from videos by Mr. Kim Singh, who also happened to release a solution to that same question. So I thought, okay, a lot of people are coming to my channel via this channel, so let's go have a look. And I discovered Mr. Kim Singh is a math teacher, so he loves maths, he loves teaching. He also happens to love the snow. These are all things that I love. And so naturally I just started going through his content. There's some really good content on his channel, so I would recommend, if you're, say, in high school, particularly in New South Wales, working through your studies, subscribing to Mr. Kim's channel would be, Mr. Kim Singh's channel would be a good idea. There's a lot of really helpful stuff that he's putting out there, so definitely worth a look. What I'll do is I'll work through kind of part of his approach, just the part that you need to get to the answer. But I'd recommend also going and looking at his video on this. It's not on this question specifically. I don't think he was necessarily tackling this HSC 2020 extension to question 13. I think he was thinking about this inequality just more broadly. But the thing I like about the video, and I'll share a link to it, is he kind of shares a bit of a exam hack that you could possibly find useful both for this inequality and others in terms of working backwards from the destination and helping that get you to a starting point. So I won't go through all of that. I'll leave it for you to go have a look at his video. But where we can start is to say the square root of a minus the square root of b squared because that's something squared, we know it must be greater than or equal to 0. So that's a known result, and it's already got an inequality in it, so it seems like quite a handy place to start to prove what we want to prove. And again, you might say, well, how do you know to start from there? And that's where Mr. Kim Sing's little hack comes into play. So definitely something worth having a look at and adding a new little tool to your toolkit, particularly around inequalities. But from here, it's a simple expansion. So we do the first one squared minus twice the product plus the last one squared. And now the square root of anything squared just gives you what's under the square root. So we'll have a minus 2, and oops, that's root a times root b. We can put both of those under the square root sign. Plus b is greater than or equal to 0. I can bring the minus 2 root ab over, so we'll get a plus b greater than or equal to 2 root ab. Bring the 2 down and we get a plus b on 2 greater than or equal to the square root of ab as required. So that's another perfectly valid approach. I think you'd get your full marks on the exam if you took this approach.
Sonic boom!
And that's because in the question there were the words or otherwise. Now if those words weren't there, then in a way you'd kind of be forced to take this approach, I think. But the question writers actually left it open. They said, you know, if there's another way you can think of, go for your life, and I think this is one of those ways. So hopefully that's all made sense and you found it helpful. If you did find this helpful, please be sure to give the video a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions other students are struggling with, be sure to subscribe to my channel so that you can stay in the loop. And on the topic of subscribing, I'd also recommend go and take a look at Mr. Kim Sing's channel, Jonathan Kim Sing, and definitely subscribe to that too, because I think you'll find a lot of helpful content there. All right, tick boom.